Imagine two circles with radiuses r1 and r2. Theta 1 and 2 are half of the arc angles. This will make the calculations easier. Let's get this to 3D. We call the geometric center of the intersection area M and rotate the intersection area around a vertical axis. Note that the distance between M and the axis of rotation is denoted with capital R. Our goal is to determine the volume of this ring shape in terms of R1, R2, theta 1, theta 2, and capital R. Try this problem on your own. The method is actually very simple when you discover it. I hope you took your time. Now, I will try to build up a formula that will allow us to solve this problem and every other volume problem involving circular rotation. Start by thinking a circular sector with radius r and denote arc length with letter S, which is equal to r times theta. In radians, theta will be S over r. How do we represent the volume of this sector? PAR squared is the area for a full circle. However, in this case, we need to multiply it by theta 2 pi, which will yield the formula area equals theta times r squared over 2. If we plug d over r to theta, we get the formula that area equals S times r over 2. Let's use this formula for a case more closer to problem. Now rotate a line around a center and define the following lengths. R1 and R2. Arc lengths are theta multiplied by R1 and R2 respectively. If we write the area equation for the larger and smaller circular sector and subtract them, we get the area inside the blue lines. Let's put this equation aside and try to find the same area with a different way. I define a third arc called S3 at the middle of these two arcs. Therefore, R3 equals R1 plus R, 2 over 2. The length of the line we rotated is R2 minus R1. If we multiply the center arc length and the line length by using the difference of two squares, we get the same result for the area as before. Therefore, we conclude that area is length multiplied by the trajectory or path of its center. We can further adapt this to our problem by increasing it one dimension. The volume equals the rotation area times the length of its center's trajectory. Of course, this makes sense initially when we first look at the problem, but we indeed proved it rather than feeling it. Now, we should find the area of the intersection. First, find the area of the green sector, then subtract the area of orange right triangle to find A1. Secondly, repeat the same procedure for the other circle to find A2. The intersection area, which is denoted with I will be equal 2 times A1 plus A2. I will leave the rest of the problem to you for now and will release the full solution next week. Please write down your solutions in the comments down below and don't forget to stay tuned and subscribe for more high-quality math content.